Okay, in the last class we have discussed about the importance of special purpose register, special function register or special purpose registers. What are those? Those are nothing but code segment register CS and data segment register DS and stack segment register SS and extra segment register, stack pointer, base pointer, instruction pointer, source index and destination index. So the main function of this special purpose register is used to hold the address of the memory location. Okay, but the address of the memory location is 20 bits. Why? Because the address lines for the microprocessor 8086 microprocessor, the address lines are 20. But in internal register size of every register size of 8086 processor is 16 bit. It can hold only 16 bit information. So that's why in order to provide 20 bit physical address for the memory, we are going to divide this 20 bit physical address into two 16 bits and divided into two 16 bits, and these two 16-bit address we will call it as one address, call it as base address, and another address is call it as offset address. So here the code segment, data segment and stack segment and extra segment will hold the base address of the memory location, and stack pointer, base pointer, instruction pointer, source index and destination index will hold the offset address of the memory location. Okay, so that's we have discussed in the previous class. So today we will discuss how to generate a 20-bit address, 20-bit physical address. So for that, the manufacturer provided how to find out the physical address for the memory. So for that, the formula is base address into 10H plus offset address. So by combining base address and offset address, we can get the 20-bit physical address. See, the size of the base address is 16 bit. Okay, the size of the base address is 16 bits and the size of the offset address is 16 bit. Okay, so if you directly add base address and offset address 16 bit, we will get around 16 bits or 17 bits. But how can we get 20-bit address? That is the question. So in order to get 20-bit address by using two 16-bit registers, we are providing a formula is called base address into 10H. So if you multiply any number, any hexadecimal number into 10H, then what happened? For that number, suppose the number is 2, 3, 4, 5 H into 10H, then these 4 digits will become 5-digit number like this. Okay, so that is the reason. See, now the 4 digits number will become 5 digits, which is nothing but 20 bits. 5 hexadecimal numbers are nothing but 20 bits. Okay. So that's why base address will be multiplied by 10H and the offset address is added, so that the resultant value will be 20 bits. So this is very important formula. The physical address, this is the formula. Okay. Now we will see how the CPU can access different memory locations. See, so this is the diagram. See, this is a memory. So in the memory, suppose if a code segment so now we will see by animation how CPU can generate physical address. Suppose let us consider this is a memory. So in that memory, suppose CPU is accessing only code segment memory part. Since the code segment CPU is accessing the code segment, then the base address is taken from the code segment register. And the offset address is taken from the instruction pointer. As soon as the programmer loaded the program into the code segment memory, then the compiler will automatically compile the base address of the memory, starting base address of the memory, and the offset address of the memory. So here, suppose for example, code is start loading from the 20,000 H memory location. So here 20,000 H memory location, there is a instruction 1 is there. In the 20,001 H memory location, some data is there. So likewise, up to FFFH, the program is loaded. Okay, so as soon as the program loaded into the code segment memory part, the compiler will compile the base address and offset address of the starting of the program and load it into the corresponding segment register and into the corresponding offset register. Offset address will be loaded. Okay, now if you press execution button, then the CPU will take in the base address from the code segment register and the offset address will be taken from the instruction pointer. Why? Because CPU is accessing code segment memory, so by default, base address will be provided from the segment register, code segment register, and the offset address will be taken from the instruction pointer. That we have seen already. For corresponding segment registers, so corresponding base segment register will provide the base address and corresponding specified register will provide the offset address. We have seen that. So likewise, if the base address is 2000 and offset address is 000, then if you calculate the formula, what is the formula? Base address into 10H. Formula is what? Base address into 10H. So what is the base address here? 2000. So 2000H into 10H. So what will be the value? It is 20,000H. And what is the offset address? It is 000000H. So the entire address will be 20,000H. So this is how CPU will generate the 20,000H address and it can access the first memory location. Then whatever the instruction is there, that will be read from the memory and loaded into the instruction register. and then it will execute the instruction 1. So after every instruction fetching is over, then the automatically offset address will be incremented by 1. So the property of offset register will be what? After every fetching operation completes, the address in the instruction pointer will be automatically incremented by 1. So then CPU, in order to execute the next location, memory location, then it will again taken the address, base address from the segment register, code segment register, and offset address from the instruction pointer. Now the address will be what? 20001. So from this 2001 memory location, that is a data. So that data will be taken into the data register. Then it will execute the instruction. So after every instruction execution completes, the offset address will be incremented by 2. Now the base here you can see, you can observe one point, that is, in order to access the different memory locations of the memory, here only offset register will be changed, but the base address is fixed one. So this is a very important point you have to observe. So now the address will be 20002 memory location. Then it will activate 20002 memory location. Since it is an instruction, it will be read into the instruction register, and then offset address will be again incremented by 1. Likewise, by incrementing the instruction pointer address, we can access the different memory locations in the memory location. Suppose, for example, if it is a data segment memory, then here the base address will be provided by the data segment register, and the offset address will be taken from the BX register or SI register or DA register, like that. So in detail we will see in coming sessions. Okay. So likewise it will execute up to last instruction, it will be execute, then it will be stop the execution. So this figure will show the segment memory locations in the entire 1 megabyte of the memory. So here the capacity of microprocessor is what? It is the maximum memory size is what? 1 megabyte. 2 power 20. This is nothing but 1 megabyte. So in the 1 megabyte memory, we are having 4 segments. So data segment, code segment, and stack segment, and extra segment. Okay, so this is extra segment, not stack. This is extra. See here, suppose if you see the data segment, so data segment is starting from 20,000 H memory location and end with 2FFFFH. Okay. Why it is FFFH? As I already told, suppose if the starting address of any segment is 20,000, then what is the base address for that memory location? 2000. Okay. Why? Because we will add into 10. So that will be 20. Then offset address. Okay. So here, why this maximum last memory location of the segment is 2FFFH? Because the offset address will be vary from what? 00000 to maximum address is what? F. So if you add 00000, then you will get bottom address of the segment. If you add FF to the base address, then you will get top address of the segment. So that's why every segment memory location, every segment memory size will be 64 kilobytes. means the total size is what? 4f. 4f means what? 16 ones. So 2 power of 16 means 64 kilobytes. This is how we can calculate the maximum size of the memory location. So how many number of ones are there? 16 number of ones are there in the final memory access. So if you want to get the size of the memory, then 2 power 16, whatever it may be. Suppose if your last number is 8 ones, then how can you find out the size? Entire size 2 power 8, which will give 256. So this is the maximum size. So maximum memory size can be find out what is the last address and how many number of ones are there in the address. Okay. So similarly, you can see this is the starting address of the memory location of the code segment, and this is the end address of the segment. So we can easily find out. See, here the base address is what? 348A0H. This is the physical address, 20-bit physical address. So 348A0H. Then what could be the base address for this code segment? 348A into 10H. We will add 10 into 10H, then automatically it will give. So then if you find out the base address, starting address by adding 0000, and see, you can see, yes. So here the value is 34880. So physical address is what? 348A0H. This is the 20-bit address you are assuming. So what is the base address here? 348A H into 10H. We can write like this, plus 0000H. So now what is the base address here? Base address is what? 348AH. And what is the offset address? It is 0000H. Now, what could be the last address of this segment? If the physical address is starting from this memory location, what could be the end address here? End address of the segment 348AH into 10H plus F. This is the last address. So what it would be? 348A0H, then F. So if you add this number, then you will get the final answer. Final value is 448FH. We get 448 9 449FH. So if you add, this is the last address. So what is the first address? This one. So you can see here, this is the last address. Similarly, stack segment is 50,000 and end address is this one. So you can easily find out. So this is about segment memory. Okay. So in the next class, we will see some examples. In the next class, we will see some example how to find out the 20-bit physical address. Okay. Thank you.